Welcome to the stage, Jan ter Meulen, presenting advancements and challenges in glasses-free 3D display optics manufacturing.
Yes, thank you for this, having this opportunity to tell more about our work. Maybe first a little bit about our company. We are a company in the Netherlands. We are located in Eindhoven, right in between ASML and Philips. It's also called the Brainport. It's an area which is really good in tool manufacturing, and this is also exactly what we do. So we are an equipment supplier of large area nano imprinting tools. That said, a tool never works alone without a process, so we also develop the process and the materials, and we also sell the consumables. We have a nice team of 40 people developing the materials, developing the process, and giving the support to our customers. Actually, that was already this slide. Then, if we go to the next slide, then the previous, I'm sorry, this one. Our focus is on the display market, and there are a lot of developments in the display markets. We are in the display week, you can see it. So AR, VR, foldable phones, anti-glares, it's a topic. And then, of course, 3D. And all of these developments, they benefit from having optical structures. Display is an optical device. If you want to improve the performance, you should think of improving the optics. Obviously, you cannot add bulky lenses, so you should think of small, micro, or nano lenses, which you can easily integrate. And it's not a surprise that if you look over the last 10 years, you see a big growth in the number of patents written on the topic of microstructures or nanostructures. So how to integrate those micro or nanostructures? Yeah, and this is exactly what we do, where we come in. So we do this for the different applications. One of the applications is 3D, and we think that 3D is one of the first applications which is now really starting to pick up. And this is, yeah, you can see it here around all the display manufacturers. They show a 3D display. And then you have different designs. You have switchable, you have non-switchable designs. The main thing that there is a big difference from 10 years ago. 10 years ago, there was no content. Yeah? You had to wear glasses. If you look today at the different displays, well, there's still a difference in quality, but you can see the 3D, you can see the depth without glasses, and content is not an issue. So how can they make it? Well, clearly in the last 10 years, the resolution of the display have been improved, so they use the different, the high density of the displays to steer the image to the left eye and then other image to the right eye using the optical elements. So the whole development of 3D benefit from the high resolution. They benefit from the strong chips, converting any 2D movie into 3D. There's basically not a content issue anymore. There's a 5G network for rapid data streaming, and there's obviously an overlap in AR and 3D in the same depth calculations. So they benefit from other trends in the market. So everything is there to bring 3D to the market. There are a lot of proto displays, but how to ensure good quality in mass production? Whatever, now it starts, how to ensure the high numbers. If you think about the production method, you would like to think of different constraints, different parameters. So first of all, it should replicate the lenses well. So you need a good replication of the quality. And whether today the lenses are 50 micron and maybe in 4 years they are 10 micron, you should have freedom in design. It should not be just only replicating one design. Yeah, you should have margin, process margin. You should be able to replicate the lenses on a small size for the current 32-inch, as well as up to the 65-inch or even larger. So you need scalability. accuracy, and a high throughput. And that's exactly where our tools come in. So these are the points where we have a solution for, which looks, or what we handle in our roll-to-plate method. So how does such a roll-to-plate method look like? It all starts with a master. We are not a mastering company. There are various mastering companies. And for 3D, typically you could use a milling mastering technique. And milling can be done on large area. Gen 5, Gen 6 is available. So it starts with the master. From the master, we copy a flex stamp. So that's the inverse texture. And it's not just simply a copy. You have to ensure that this flex stamp does not adhere to the later on, to the product, to the display, to the optical structure. So you add anti-stick functionality. Well, and here a lot of material development comes in. We have materials which can last over 500 or even 1,000 imprints without any degradation. So you have the stamp is pressed in the resin, in the UV curable resin, and then you can also think of developments in the resin, for instance, developments in resin with a different refractive index. The resin is applied on the substrate. That can be a glass, can be a foil. Typically glass is more flat, has a higher quality. Well, you can do both. Then the flex stamp is pressed into the resin. It's cured by UV curing. It's a direct curing, and then you can immediately delaminate the flex stamp again. So this is also a quick process. Every 1 or 2 minutes you can finish a product. And it's a scalable technology because you can scale the length of the rotor. And then you have a mass production technology. And that's exactly what the market is looking for. So where are we? Well, obviously we can replicate the lenses well with a low crosstalk. You can think of lenticulars, lens lines, like the old postcard which you could buy at the zoo. But nowadays the lenses are for smaller, micro lenses. You can also think of micro lens arrays for more holographic devices. We have our own material development, developing resins between 1.4 or 1.6 refractive index, but there are also suppliers like Pixeligent which can supply higher refractive indexes. We can replicate on Gen 5 or even Gen 6 is being discussed. Currently we can replicate up to 65 inch, which comes at a cost which is on par what the display makers are looking for. And that is really important because if you want to make this a success, you have to have a fair cost. People like the 3D concept, but they are not going to pay hundreds of dollars to add this functionality. With our technology, we are well below $1. You can think of 50 cents for a smartphone. There are other options. You can also think of a combination of imprinting and etching. How do we do this? Well, we have different tools. This is our latest tool. It's now being made based on a customer order. It's a fully integrated line which has the different stages, the primer to promote the adhesion, the coating step, and the imprinting step, all fully automated to have every 1 or 2 minute product produced. And then you can think of a production of more than 10 million of easy, 10 million of smartphones per year. It's a proven technology. We have commercial products in the market. Our tools are all over the world, in the US, Europe, and Asia. It's used for 3D, but you can also think of other applications, anti-glare, AR, but also topics like biosensors. And in all these markets we have customers. So that brings me to the last slide. A lot of developments in the display market. Quite basically all of these developments, they benefit from micro and nanostructures as optical structures to enhance the optical performance. We are a company which can supply or which can make or which can supply tools making these micro or nanostructures in large volumes. Basically, we are the only company providing such tools on Gen 5 size for mass production. It's patented. We work with all the larger players, and 3D benefits definitely, but also other applications. Yeah, and that's where I would like to stop. We have a booth. It's booth 1439. It's over there. Please pass by, and then we can discuss in more detail. Thank you.